Can stone bend without breaking? The landscape of Hampi is dominated by massive granite architecture that has stood for centuries. Many horizontal stone elements holding up these ceilings appear dangerously thin. By modern standards, they seem too fragile to carry the massive structures above them. Raw stone is incredibly brittle. When placed under extreme or uneven pressure, it does not stretch, it fractures and splits. Modern engineers rely on steel reinforcement to help stone and concrete cross large gaps. These temple spans have survived for 1,000 years without any hidden metal support. This longevity suggests an advanced structural logic integrated into the very shape of the architecture. Today, we use computer simulations to calculate weight distribution. Ancient builders achieved the same results through generations of observation and physical testing. There is a clear distinction between the massive, protective core of these buildings and the delicate, overhanging elements on the exterior. Builders intentionally manipulated the geometry of these structures to protect stone from reaching its breaking point. To understand how this works, we must trace the engineering from the microscopic limits of the stone up to the massive design of the temple. While it appears rigid, stone actually possesses a minute capacity to flex under load. This is elastic deformation, the way a material's internal structure shifts invisibly when weight is applied. Ancient builders managed the environment surrounding the stone, so the internal stress never crossed that red failure line. Precise mathematical control of forces keeps the stone safely within its elastic limits. This knowledge was gained through centuries of empirical data. Builders observed which structures stood and which failed, passing that information from master to apprentice. Structural failures taught successive generations exactly where and why stone breaks under specific loads. This experience led to a sophisticated system of material selection, matching different stone types to the physics required for each part of the building. Dense granite provided foundational strength, while softer soapstone was used for the intricate, weight-sensitive upper sections. If you had to build a roof, would you choose steel, concrete, or stone? Tell us in the comments before we examine the structural system that holds it all together. Every material choice was an engineering decision designed to defend against the constant pull of gravity. The overall geometry of the temple channels weight away from the most delicate stone elements. The immense weight of the roof is systematically funneled through specific load paths, rather than being allowed to spread randomly. This sequence of transfer moves weight out of the wide roof and into these horizontal structural nodes. Stepped brackets act as specialized catchment zones. They push horizontal stress down into the vertical pillars. Deeply carved spaces serve a structural purpose. By removing dead weight, builders reduced internal tension while maintaining high compressive strength. The intricate beauty of the carvings is a functional system of weight reduction and force distribution. Material selection and geometry are only part of the solution. Survival depends on how these elements interact. The temple operates as a highly integrated system. The stability of every single beam relies on the perfect alignment of every pillar. While modern buildings are often modular, these ancient structures behave as one continuous, rigid organism. Ancient architects mastered the limits of stone to build spans that remain structurally sound over a millennium after they were set in place. The masterwork of these monuments is the invisible physics acting upon every carved surface. Ancient builders understood the material's limits so completely that they made stone perform beyond what many modern observers think is possible. If you enjoyed this mystery, don't forget to like the video, share it with a friend, and subscribe to Untold Indian Stories. Could modern engineers recreate these temples using only ancient tools? Let us know below. Until next time, keep questioning the impossible.